I wouldn't have recommended it, but you could have. All right, zoom in. You guys see this okay? Can't see y'all, so I'm going to assume that's a yes. If not, let me know. All right, so we were talking about point slope form, and like I said, point slope form literally is what it sounds like. It's how you build an equation when you're given a point and when you're given a slope. Just like slope intercept form is when you have a slope and a y-intercept, point slope is when you have a point and a slope. Okay? So it says, use to write the equation of a line when given a point x1 and y1. Remember, those are ordered pairs in order to actually find the point and the slope of a line. Be sure to distribute and solve for y. Now, you have this formula on the star chart in Canvas. It's in one of the yearly resource documents. But I'm going to go ahead and give it to you now. The formula is y minus y1 is equal to m parentheses x minus x1. So again, that's y minus y1 equals m parentheses x minus x1. Now, I know as you look at that, that is rather intimidating. There's a lot of variables and not a whole lot to work with. But we're going to go through it. This is, in my opinion, one of the easier methods to deal with. There's a lot less moving from side to side once you put in the first couple pieces. So here's what it says. It's asking us to find the equation of the line given the point and the slope. So again, I want you to understand what I'm saying in this. We can only do point slope form when we're given a point and a slope. Now, when we think about a line, there are millions and billions of points on that line. Agreed? We just have to be able to figure out what they are. For these first four, though, it is literally giving us the point and the slope. So what we're going to do is just plug it in and then convert it to slope-intercept form. Let me show you that. Okay, so notice that this y does not have a y1 attached to it. And notice that this one does say y1. When that occurs, this y is the y that's going to be left alone. We're never going to touch that one. So for our first step, we're going to literally just write y minus. Now the ordered pair in this first example is 4, 1. So what is the y value given to us in this ordered pair, or should I say this point, Evan? 1. So I'm going to take that 1 right here, and I'm going to substitute it in for my y1. No issues on that, right? Okay? Now this is going to be equal to, anybody remember what m stands for? Slope, right? M is slope. And it tells me that slope is 2, so I'm going to plug in a 2 for my m. We're all okay there? Okay, now for this last part, I've got some parentheses. Now I do have x minus x1. Do you think that I'm going to plug in for the x or the x1? The x1, good. What am I going to put for the x? I'm going to leave it as x because it's a staple of the equation. Minus 4. All right, so before we start messing with this equation, I want to show you everything once again. y minus minus y1 equals m2 parentheses parentheses xx minus x1 minus 4 parentheses parentheses. Yeah, what's up?
I'm just kind of confused how you got 4.
How I got 4. So here's my ordered pair right here. So this is the point on the line. So for point slope, and do you agree that this point is conducive of x values and y values?
Yeah.
Does that help?
Yeah.
Are you sure? If not, let me know. I'll try to explain it again.
No, I get it.
Okay. All right. Now, y'all, this is just an equation. And we're trying to get everything to slope-intercept form. Because if I asked you to graph this right here, could you do it? No, it's kind of confusing. But if we convert it to slope-intercept form, then we've had that practice. We just bang, bang, put it in there. So here's what we're going to do. Parentheses first. Can I do x minus 4? No. So what do I need to do with that x minus 4? Stone. Distribute. Good. So now I'm going to have y minus 1 is equal to 2 times x, which is 2x. 2 times a negative 4, which is minus 8. Okay, so far so good. Okay. Anybody want to take a guess at what I should do next? What should my following step be? Hayden, what do you think?
Add the negative 1 to the other side.
Yeah, great job. Y equals 2x minus 7. Now what is that form in right now? Slope-intercept form. Can you graph slope-intercept form?
Yes.
Boom, boom. Easy money. Let's do one more, and then I'm going to tie into why this is important. Okay? Let's do one more, get a little more feel for it. Then I'm going to give you some real-world examples of why we need to know this formula opposed to just having slope-intercept form. Okay? All right. Would somebody be willing to set up this next equation? Anybody feel confident enough? Steven, let's give it a shot.
Number 2.
Yes, sir.
Just setting it up.
Yeah, will you just tell me like how to make it look like this?
Yes. So it would be y minus 4 is equal to 1/2 times x minus 2.
Beautiful. Well done, Stephen. Well done. Everybody see how Stephen did that? We might like me or Stephen to explain that to you again.
Yes, sir.
Okay there? Okay, now, let's convert it. Okay? It's the same process every time. So I'm literally just going to distribute that 1/2 to the x minus 2 in parentheses. If I do that, I end up with y minus 4 is equal to 1/2 x. Notice I did not convert that to 0.5. Why did I not convert that to 0.5? Why, Ben?
Because you don't use decimals and slopes.
Good, because if my slope is a decimal, I have no idea what my rise over my run is, so we want to leave it as a fraction. 1/2 times the negative 2, I believe, is negative 1. I think, correct me if I'm math wrong, I'm pretty sure that's, I always mess up when I'm dealing with halves. Don't ask me why, I'm not trying to be funny, I just always mess up. Now I'm going to add 4 to both sides. We're going to have y is equal to 1/2 x plus 3. Ever heard that sound come out of someone in algebra, but I appreciate it though. All right, so let's talk about the importance of this. Can we agree that a point on a line is representative of a specific amount in a problem? So let me give you a better example of that. Check this one out. So I'm going to have y equals mx plus b. Okay? M is going to be $30 and b is going to be $5. Okay? So what I'm going to do, I'm going to say that you're going to a Rangers game. Okay? To go to the Rangers game, it is $30 per ticket, meaning that however many tickets you buy have to be multiplied by 30. Can we all follow that? Plus $5. Can anybody give me an example of what this $5 could be at a Rangers game, Charger?
Admission fee, something? Parking.
Parking, beautiful. That's where my head's going with this. It could be other things, but so let's just take this example. You and your family are going to a Rangers game, right? It's $30 a ticket, so you have to multiply X by however many tickets you're going to buy. I'm sorry, 30 times however many tickets you're going to buy. If you have 2 people going, 4 people going, 6 people going, 10 people going. Why is this $5 charge only taking place once? Why is this $5 charge taking place once? Addison. Because you're only parking once. Now, obviously, we can get into the details of, oh, well, like if we meet up there, or if we have 10 people going, there's too many people for a car, yada, yada, yada. Yeah, I'm not worried about those what-if scenarios. I'm talking about, theoretically, if your family goes to a game, you take 1 car. Agreed?
Yeah.
That's where this $5 comes in. Okay. So now, we could also take the approach, and I could say, hey, we're going to spend, 4 people are going to this, right? But we want to figure out what the y-intercept is. Just like last week, we could take the point and the slope and plug them in here to create this equation to then graph from there. Everything we're doing is all revolving around the same ideas. It's just given, it's letting you know what you're given. Okay? A question might also say, hey, $30 per ticket, 10 people are going, this is your total price, how much is parking going to cost? Maybe your grandparents say, hey, we're going to cover your parking, and they want to know how much you're going to have to pay. Well, you might not know that answer off the top of your head, so you're going to use the amount of money that you have and the amount of people that you're going to calculate what that B value is going to be. Because notice that's the difference here. I'm not given my y-intercept in this problem. But once I plug it in here, it produces the y-intercept. Does that make sense? Everything you're doing is going to slope-intercept form. Everything you're doing. That is the whole purpose of this, is to get to slope-intercept form. Hayden, what's up?
Why? So x1 is going to be the y-intercept every time.
The x1? No, not necessarily, because look,
X1 is...
you have a -4 here, but I had to also add that 1, and I also had to multiply it by 2. Does that make sense? Okay, questions on that? All right, I'm going to scroll down. Actually, what I want you to do is I want you to try number 3 on your own, just so that we can kind of see where we're at, get a comparison. I'm going to scroll it up so I can see what's next on the notes, and then I'll clear out that. But we're going to do number 3, okay? Sorry, I know you're already know me. So number 3, this one right here. All right, here I am. I set up the equation. Y minus 0 equals 2/3 parentheses x minus a -6. How many of you guys forgot to do the x minus a negative? How many of you guys just put 1 minus sign there? Okay, yeah, that happens sometimes. Okay, I want you to see something though. This minus sign is in the problem. Remember when I gave you the formula a few minutes ago? The minus is in the formula, meaning you cannot change that. The negative is coming from this specific point. And what does it mean whenever I have a minus and negative? It adds them together, right? So again, I'm going to make a big plus sign to show you what I'm talking about there. Minus and negative always becomes a positive. And if you miss that, you're going to get different answers. So be aware of that. So now what I'm going to do is I'm going to do 2/3 times x. So I've got y minus 0 equals 2/3x. And then 2/3 times 6 is what? 4? Okay, so now I'm going to add 0 to both sides. Simply doing this just to make a point of it. We good with that? Questions there? What's up, Kate? Negative what? Okay. Are you okay with that? Any issues? Okay, one more for good luck. Try number 4. One more for good luck.